Niantic. Where, Thomas, are you over there? Thank you very much. Welcome.
Thank you so much for having me. All right. So very excited to be here. My name is Thomas Gewecke. I joined the company earlier this year as president and COO of Niantic Spatial. And I joined when we spun our company off from our predecessor company, Niantic Labs. And I had spent a few years at Niantic Labs previously, kind of getting a really, really strong sense of our technology. And prior to that, 30 years in the media and entertainment business, working at companies like Warner Brothers and Sony Music. I joined Niantic Spatial because I am thrilled and inspired by the technology that we're building and by the vision we have for what the world could be like, and by the capacity of our technology to change how we engage with the world. And I am really excited to talk to you more about that today. So we have three major learning objectives for this session. First, we're going to talk about how spatial intelligence is transforming a variety of industries, and in particular, how it can drive real, measurable impact at your organization. And second, we're going to explore some real-world enterprise applications, customers we're working with today, from workforce training to customer engagement and even search and rescue. And finally, we're going to talk about how AI-powered spatial computing is redefining how businesses interact with the physical world. So at Niantic Spatial, we're doing something incredibly cool. We're building a living model of the world that people and machines can talk to. In some ways, this is a brand new thing. I mean, as I mentioned, we just formed our company 4 months ago. But in fact, what we're building today is the culmination of nearly 25 years of thinking about what it might mean to build a new kind of map. Our founding team is the same team that started Keyhole 25 years ago. I'm sure you're all familiar with that startup, which became Google Earth. It was a revolutionary new way of thinking about maps and about trying to make them easily accessible to anyone. And that same team went on to build the mapping business at Google, and then 10 years later, invented the genre of real-world walking games and changed the world again with the global phenomenon of Pokemon Go and many other experiences. Now, to make those games work, we had to build a whole new way of capturing and seeing the real world. You can think of it as another new kind of map. And so with this new company, Niantic Spatial, we're building a new kind of map for the third time. We started by putting an interactive model of the world on a screen with Google Earth for billions of people to enjoy. We went on to build this amazing new technology, a real-world spatial computing stack that fuses the digital and the physical to power walk-around games and experiences that hundreds of millions of people have experienced. And now we spun all of that technology off into this new company, Niantic Spatial. We're combining it all with the power of geospatial AI to, again, create something that's fundamentally new, what you might call a third-generation map. The smart, living model of the world that truly connects atoms to bits, that turns physical space into a kind of programmable surface that, in effect, that in the world of AI and robots and AI glasses, it creates an entirely new medium from the fabric of the world around us. So we're building on all of our history to bring what we think is an extraordinary new vision to life. A large geospatial model that will transform how we engage with the physical world. Okay, so what does all that really mean? Let me show you a video that walks through how our system works in just a little more detail.
Niantic Spatial connects AI with the real world, bringing intelligence to the places we live, work, and explore. We do this by building a large geospatial model that people and machines can talk to. It starts with a traditional digital map with tens of millions of landmarks and local businesses. A 3D base map adds dimension, enhanced with high-resolution scans of the real world, from aerial platforms like drones to ground-level sensors like phones, robots, and AI glasses. Those fragments are processed, aligned, and georeferenced, then used to train a series of powerful models. In a sense, this is a map built for computers, not for humans, to help machines understand and interact with the physical world. Once complete, these models provide 3 key services. Reconstruction transforms raw scans into detailed 3D visualizations, powering inspection, simulation, and collaboration. Localization enables precise navigation, contextual insights about the world, and AR experiences. And with semantic understanding at every 3D point, our map can answer open-ended questions about the world, giving people and machines the context they need to navigate, interpret, and understand large spaces. Together, these services bring intelligence to the real world, powering AI, wearables, and robotics, and helping machines truly understand the world around them.
Okay, so we have these 3 core capabilities at the heart of Niantic Spatial. Reconstruction, which transforms raw scans into detailed, immersive 3D visualizations, can power things like inspection, simulation, collaboration, and much more, a huge variety of enterprise use cases. And we have localization, which anchors intelligence to the real world. It enables precise navigation, contextual insights about the world, AR experiences, the overlay of real-time telemetry onto the physical space. And our final 3rd layer is understanding, semantic understanding at every 3D point. And with that, our map can answer these open-ended questions about the world, giving people and machines everything they need to understand what's really going on. So let me talk a little bit about reconstruction just a little more deeply. With reconstruction, we create these extraordinary, high-resolution, immersive visualizations of the real world. Now, these are very high-density Gaussian splats. We can combine them together to a space of almost any size to create these incredible experiences, delivering a beautiful, effortless journey through any space, whether indoors, as in this example, or outdoors, as in this incredible capture of Pier 39 in San Francisco. And in this example, we're doing something really special. We're using our unique technology, which lets us take multiple scans from multiple sources. So we can have footage from drones, we can have captures from specialized handheld cameras that you walk around with, we can have captures from a regular mobile phone, and we can bring them all together and combine them to create a single integrated rendering that you can then experience through any camera path. It's a full 3D model. You can do anything you'd like with it, as well as display it in this incredibly compelling way. And so this technology lets us scan much larger areas, not just a 10 by 10 or 20 by 20 point of interest, not just a home, like I showed in the first example, but something more like a city block. You think plazas or parks or industrial sites. There are endless applications for this kind of powerful visualization. For example, we're partnering with a company named Echelon, which operates some of the most advanced flight simulation platforms in the world. And using those simulation environments, we're planning to test precisely these capabilities with the United States Coast Guard at their National Aviation Training Center. And we're going to start by integrating critical locations like helicopter landing zones, simply to make the existing training and simulation environment much more realistic, more up-to-date, more accurate, more detailed, basically a better experience. But much more is possible in the future. If you've used our Scaniverse application, which is available on the iOS and Android platform, you can download it today, or we have some amazing demos of it downstairs at our booth. You know that we can capture an incredibly detailed 3D model of an outdoor space on your phone in 60 seconds. And you can imagine in the future a scenario where a pilot is on their way to a rescue mission at a landing zone that perhaps they've never used before, or whose topology is fundamentally changed because of a flood or a hurricane or some other weather circumstance. And first responders on the ground could use their phone to scan in a detailed 3D model of the site. And they could send it to the incoming pilot, and they could view it in the cockpit on a terminal there. And they could use that to get a better sense of where they're going and better situational awareness and improve the effectiveness and safety of the rescue. And there are many, many other possibilities along those lines. So we can deliver these incredibly powerful, visible reconstructions of the real world. But that's just the beginning. Underneath those visible images, we're also activating our VPS visual positioning system. That's an invisible 3D point cloud that allows any device with a camera, a phone, a robot, AI glasses, to orient perfectly in 3D space with centimeter-level precision. That lets us anchor persistent content to any voxel. So in effect, you really can treat the real world as a programmable surface, as a kind of screen, as a new medium. And again, with this kind of technology, there are just an incredible number of applications. Just as one example, Mitsubishi Heavy Industries Aero Technologies Group is using both our localization and our visualization capabilities together on phones and on AR glasses to support super precise, mission-critical inspection and maintenance operations. Now, our initial focus in this project is on helicopter maintenance, but we also see future applications for large, heavy transport like ships and trains. And downstairs in our booth, you will also see our partner Sphere, who has a lot of other examples of similar applications, combining our technologies together in a wide variety of remote maintenance and collaboration applications. Or let me take an example from a very different industry. We're working with our partner Meow Wolf to test the limits of what's possible when you really take seriously this idea of thinking about the world as a canvas. Now, Meow Wolf, as you may know, is a fundamentally new kind of entertainment company. They're an incredible immersive art adventure that you could visit. They have locations in Santa Fe, in Denver, Las Vegas, Houston, right here just outside of Dallas, new locations coming in New York and LA soon. Their mission is to inspire creativity in people's lives through art and exploration and play so that imagination will transform our worlds. Now, with Meow Wolf, we and they are partnering together to use our localization technology to, in what we think are beautiful, clever, unexpected, subtle ways, to help bring the magic of the Meow Wolf experience out into the real world. And we want to help visitors start their experience out in the real world before they even get to one of the destinations. And you can see in these images how our ability to fuse digital content to the real world in super precise ways, centimeter scale precision, helps deliver this blending of the real and the imagined. And in the process, really helps create a truly one-of-a-kind immersive experience. This summer, we announced a major partnership with Snap to bring all of these localization capabilities into the Snap ecosystem. And AR developers will be able to use Niantic's visual positioning system to place AR content at millions of real-world locations, again, with centimeter-level accuracy. And this partnership includes integrating VPS into spectacles to enable AR interactions that both serve everyday needs, but also spark fun experiences. And we're really, really excited about the possibilities here. And just yesterday, we were thrilled to announce a new partner, Kojima Productions. So marking their 10th anniversary, we'll be working alongside this visionary studio team to bring the rich, imaginative world of Kojima Productions into the real world. Our geospatial AI will power an immersive experience that weaves its narrative directly into our surroundings. So it's a new chapter for Kojima Productions as they expand into new forms of media. It's also a testament to the power and potential of Niantic Spatial's geospatial technology. And I want to give you a little teaser on what to expect.
Reach to the stars. Dream with your heart. Fading away will break you apart. Stand up, stand tall as you are.
Can't wait to live in that world. You can see we are really serious about this idea of planet-scale fusion of the digital and the physical world, and bringing all of our services to the entire outdoors, to the entire indoors, and making magical things seem real. So we're building a smart, living model of the world that machines and people can talk to. And we're building it in these multiple layers. We have our visible reconstruction layer that delivers incredible 3D visualizations of any space. We have the invisible scaffolding of VPS that overlays on top, that makes the real world accessible to computers, lets us navigate and act upon the world, turning it into a new kind of medium or interface. And these are capabilities that we are live in the marketplace with today, solving real business problems and transforming the customer experience. But what we're building for the future is even more exciting. Our layer of understanding, our semantics layer, to seismic leap forward, whose goal is to deliver an almost magical level of understanding of the world around us. Sometimes we call it an almost human-like level of understanding. Because if you think about it, any human being without any training can stand anywhere in the world and just instantly, intuitively apprehend tens of thousands of pieces of information about what's around them. What are the objects? Where are they? What is the relationship between things? What's the spatial organization of the location I'm at? What is the significance and meaning of all of those configurations? It's instant, it's built into how we perceive the world. But a computer or a robot or an LLM today simply doesn't have that kind of innate spatial context or understanding. The Niantic AI system understands the physical world in exactly that nuanced, layered, and human-like way, enabling interpretation and querying and action. And this semantic understanding means that we can answer open-ended questions about the world, and it means we can provide this context that's needed to truly interpret and understand. We have an incredible demo downstairs in our booth that gives you a snapshot of exactly how this could work and how powerful it could be, and that really sort of sparks the imagination when you think about how it could be applied to the data that you have. So just to close it up, we are building for a future of AI glasses, wearables, robots, and people in the world. It's a world where, if you want, every look can be a search, sort of a query against the new medium of the real world. It's also a world where, if you want, every glance can be an update. It's new ground truth that's coming into the model. When we talk about a living map, a smart map, a self-repairing map, that's what we're talking about. We're creating a global ecosystem in which every use of our model helps make the model better. It makes our understanding of the local scene better, makes our understanding of every scene better. And that's how we get to a living model of the world that people and machines can talk to. It's a new invention that will transform how we interact with the world. It lets us touch the real world with all the power of geospatial AI, but it also keeps humans at the center of the story. It's yet another new map for a brand new world. And so if you're building an AR or robotics or spatial AI, come talk to us. We're at booth 508. We've got demos, we've got swag. We have a whole team that's excited to meet with you. Thank you very much.
I think we probably have a chance for 1-2 questions, maybe, if anyone's got a question. Or is it lunchtime? I have one here, Thomas.
I'm from Southern California Edison, a utility company. And so by looking at this, where can I leverage this to? So maybe use case?
Yeah, so I think a very large number of use cases. I mean, it depends. We have partners who are using this to do just visualization, for example, to inspect important, whether it's power substations or utility lines, and just kind of get great, powerful reconstructions to communicate the state of them. We are including, for example, taking drone footage and phone footage and even civilian, captured footage and putting it all together into one model. With our VPS capability, you can overlay any existing telemetry on this. You can let a technician go out and annotate, sort of in real time, and let somebody else come out later and look at whatever they've annotated. And so you can kind of take a sort of, a call like that and make it a persistent digital record. One of the most exciting things we're doing is combining all of those technologies together with semantics to do things like, scan an entire neighborhood, look at all the power lines in a neighborhood, look at all the trees in a neighborhood, and come up with an instant assessment using our understanding capability of whether there's a fire risk, for example, or a safety possibility because of the proximity of the trees to the power lines, just as one example, and sort of an infinite variety of those kinds of use cases and applications.
Amazing. Thank you very much,
Great.
Thomas, indeed. Thank you.
Thank you.
Okay.